Sketch the graph of y equal to 2 cos x plus 90 plus 1. This is a question on trigonometry, mathematics pure 1, pure mathematics 1 A levels. So we first sketch the graph of y equal to cos x. This is a graph of y equal to cos x. And now we sketch y equal to cos x plus 90. So what happens? There's a translation by minus 90 0. So the x coordinate moves backwards by 90 degrees by 90. So this will be the graph of y equal to cos x plus 90. 90 0 becomes 0 0, 270 0 becomes 180 0, and so on. And now we sketch y equal to 2 cos x plus 90. Stretch factor is 2. So it is stretched by 2, so minus 1 and 1 goes to minus 2 and 2. Everything else is the same. And now we sketch 2 cos x plus 90 plus 1. So there is a translation of 0, 1. So the y coordinate moves 1 unit upward. So from minus 2 to 2, it goes to minus 1 to 3. So this would be the graph of y equal to 2 cos x plus 90 plus 1. Sketch the graph of fx equal to 3 cos 2x, where x lies between 0 and 360. Write the period and amplitude of f. So first we draw fx equal to cos x. This is a graph of fx equal to cos x. Cos 2x. Cos 2x, the x coordinate gets replaced by 1 by 2x. So 90 0 will become 45 0. 270 0 will become 135 0. So this would be the graph of cos 2x. And 3 cos 2x. You are multiplying y coordinate by 3y. So when you have 1 0, it becomes 3 0. Minus 1 0 becomes minus 3 0. So this will be the graph of y equal to 3 cos 2x. The period is 180 because it's repeated. After 180, there is a repetition and amplitude is 3, minus 3 to 3. Fx equal to 1 plus 3 cos 2x. When you have the next part is sketch the graph of y equal to 1 plus 3 cos 2x. We already have 3 cos 2x. What happens in 1 plus 3 cos 2x? There is a translation of 0, 1. So it moves 1 unit upwards. So minus 3 to 3 becomes minus 2 to 4. Everything else is the same. And on the same grid, sketch the graphs of y equal to sine 2x and y equal to 1 plus 3 cos 2x for x lying between 0 and 360. So the one in red is the graph of y equal to 1 plus 3 cos 2x. Now this is a graph of y equal to sine x. What happens for sine 2x? X coordinate is replaced by half x. So you can see that 180 0 becomes 90 0, and this 360 0 becomes 180 0. So this would be the graph of sine 2x. And if you have to sketch it, I've sketched it on as orange on the same graph. State the number of solutions of the equation sine 2x equal to 1 plus 3 cos 2x, where x lies between 0 and 360 degrees. The two graphs you can see intersect at 4 points, which I have marked in green. So the number of solutions is 4. The graph fx equal to 3 sine x minus x by 2 minus 1 is defined for the domain minus pi to pi. Sketch the graph of y equal to fx and explain why f has an inverse function. So this is a graph of sine x. Sine x by 2, the x coordinate is replaced by 2x. So pi 0 becomes 2 pi 0, and this will be the minus pi 0 becomes minus 2 pi 0. So this will be the graph. And 3 sine x by 2, the y coordinate is replaced by 3y. So 1 0 becomes 0 3, minus 1 0 becomes 0 minus 3, and this would be the graph of 3 sine x by 2. What happens to 3 sine x by 2 minus 1? It shifted 1 unit downward. So minus 3 becomes minus 4, 3 becomes 2. So this is the graph of y equal to 3 sine x by 2 minus 1, and the range is minus 4 to 2, the values on the y-axis. F is 1 1 in the closed interval minus pi to pi because every horizontal line intersects the graph at exactly one point. So F has an inverse.